Hello, Algebra, and welcome to the start of Topic 4, covering systems of linear equations and inequalities. So again, when you hear this word systems, systems just means you have two or more of something. Two or more, right? So in this case, we're going to have two, right? But as you take higher level math, you might see, three variables in the future. So in systems, right? The reason we need multiple equations is to solve for multiple variables. So far, you've pretty much had one equation. It's usually x. I'm sorry, one variable, so it's usually x. So you need one equation. But if we're going to solve for two variables, say x and y, well, now we need two equations. And if you want to solve for three variables, x, y, and z, you need three equations. So we're going to be right in here, x and y land. Okay? So be aware of that as we go through today's lesson. And this lesson, lesson 4.1, we're going to solve these systems by graphing. So graphing a line is going to come into play here in this lesson. All right, so example 1 says, what is the solution of the system of equations? So here are two equations. So let's label the first one equation 1, the second one equation 2. All right, so we're going to graph these equations. So for the first equation, it is in slope-intercept form, y equals mx plus b. So for equation 1, I need the slope and y-intercept. All right, so for the equation 1, we have y equals negative 2x minus 4. So minus 4 is your b value, right? You start there, go down 4. So we're going to go down 4. 1, 2, 3, 4 from the origin. And then negative 2, this is my slope. I need to make it a fraction, so put it negative 2 over 1. And what that means is we're going to go down 2 and right 1. So from this point, I'm going to go down 2, right 1. And I'll do it a couple times, down 2, right 1. You might want to go the other way too. Since they're going down 2 and right 1, go up 2, left 1, up 2, left 1. The better graph you have, the better for you. And again, try to draw it as straight as possible. You can see that I'm doing my best here to make it straight. But it's not really doing very well. Up to left 1, up to left 1, up to left 1, up to left 1, up to left 1. And again, just try your best to draw a straight line through those points. Okay, there's that first line. Ugh. Okay. So again, this is the line y equals negative 2x minus 4. And now I'll do the second line in blue. So now we have y equals, now 0.5, this as a fraction is 1/2. I'd rather have the fraction. So 1/2 x plus 6. So now this case, the 6 is the b value. That means you go up. So we're going to go up 6. 1, 2, 3, 4, 5, 6 from the origin. And then the 1/2 is your slope. And to count that, we're going to go up 1 and right 2. So from this point, up 1, right 2. Up 1, right 2, up 1, right 2. Now, because I know that these two lines are going to cross over here, and that's what I'm looking for. I'm looking for the intersection. I'm going to go down 1, left 2, down 1, left 2. And you see, I got the point where they're going to cross by counting the slope. So notice when I connect my line, the point they cross at is right here. This point of intersection is my answer. Point of intersection. This is my answer. That's what I'm looking for, right? That point of intersection. So the solution to these equations, these systems, is the point of intersection, where they cross. And the coordinates at that point would be from the origin left 4, so negative 4, and then up 4, positive 4. X first, y second. I think that the solution is negative 4, 4. Now, you can quickly check. Quick check, right? That's C-H-E-C-K. Check. By plugging in negative 4 and 4 into each equation. So into equation 1, plug in 4 for y. So 4 equals negative 2 times negative 4 minus 4. And the x is negative 4. So this side is 4. If you simplify this or plug it into Desmos, this is negative 8, and then negative 8 minus, this is positive 8, and then positive 8 minus 4 is 4. It checks out. Because the left and right side equal, that point is on the equation line 1. Okay, check the second one. I'll do it in blue. So now I'll do, so my y is 4, so 4 equals 0.5 times negative 4 plus 6. So this is 4 equals, and again, simplify this. Half of negative 4 is negative 2. Negative 2 plus 6 is 4, and it checks out. And we're good. So this is my solution. So my solution is negative 4, 4. And that's what we're looking here when we graph these. Okay, next one. All right, same thing. It says, what is the solution? So now we have two equations. The first one is in standard form. We're going to rewrite this in slope-intercept form. Okay, so we're going to take the first one and put it into slope-intercept form. So equation 1. So I'm going to rewrite this. 15x plus 5y equals 25. So to solve this or put this into slope-intercept form, and again, let's remind ourselves that slope-intercept form is y equals mx plus b, right? We're going to subtract the 15x on both sides. So the 15x's cancel, 5y comes down. This is negative 15x plus 25. I put the negative 15x first to match the mx. And then we divide everything by this 5. And we get y equals negative 3x plus 5. And there is the first equation. Your b value is 5. Your m is negative 3. Put it over 1. So b value is 5. Go up 5. Slope value negative 3. That means you go down 3 and right 1. Down 3, right 1. Down 3, right 1. Down 3, right 1. You can also go up 3, left 1. And there's the line as best as I can draw. And now for the second one here is already solved for y, but notice that these two terms are backwards, right? The mx part is first. Let's put the mx part first. So y equals negative 3x plus 5. Notice that the negative goes with the 3x. And now notice here, look at this equation compared to this one. They're exactly the same. If I were to graph, I would go up 5, and I would count a slope of negative 3 over 1. Down 3, right 1, down 3, right 1, down 3, right 1, up 3, left 1. They're exactly the same line. So, when your two equations are the same line, where do they intersect? They intersect everywhere. Everywhere. What answer is that? That is infinitely many solutions. So if you graph your two lines and they're exactly the same line, infinitely many solutions. Let's take a look at one more here in this video. So it says, what is your solution? So again, I'm going to put these two in slope-intercept form. So for the first one, y minus 2x equals 6. It is close. I just have to move the 2x to the right by adding it. So y equals 2x. The 6 is positive. 6 is my b. My slope is 2 over 1. So go up 6. 1, 2, 3, 4, 5, 6. And go up 2, right 1, up 2, right 1, go down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1, and there's my line. The second one takes a little extra work here, so let's see if I can do it right here. So negative 4x plus 2y equals 8. I need to get y by itself, so move the x term over first, add the 4x. 2y equals 4x plus 8. And now we divide everything by 2. Divide by 2, divide by 2, divide by 2. We get y equals 4 divided by 2 is 2x. And then 8 divided by 2 is 4. 2x plus 4. The b value is the 4. Up 4. The slope is 2. Make that a 2 over 1. And we're going to go up 2, right 1, up 2, right 1, up 2, right 1, down 2, left 1, down 2, left 1, down 2, left 1. And we're going to draw the line. Now notice here that these two lines never touch. They're going to be parallel. So if the solution is the point of intersection and these never touch, these two lines, this system has no solution. No solution. If we compare their equations, notice they have the same slope, 2x, 2x. 2 is their slope, but they have different b values. That makes them parallel lines. Okay? All right, so second video is coming up here. Thanks for watching the first one.